Welcome to OpenClaw, the dawn of autonomous AI agents. We will explore the shift from passive chatbots to AI that acts, including the technology, the risks, and the transformative future of autonomous AI agents. This program is brought to you by the Series of Thoughts team as part of the Tech Topics and AI Foundation series. Chapter 1. The Promise of Claude with Hands. What if your AI could do more than talk? OpenClaw represents a fundamental shift in how we view AI, moving it from a question-and-answer machine to an autonomous digital worker capable of real action in the world. OpenClaw is an open-source agentic AI gateway. Its key capabilities include connecting to any large language model, running on self-hosted infrastructure with no cloud dependency, and integrating with tools like local applications and external services. The core innovation is agency. OpenClaw moves beyond chatbots, executing shell commands, managing calendars, and browsing the web autonomously. This gives the AI a body to act in the world and perform complex tasks. OpenClaw's persistent memory system is a powerful differentiator. It retains context across sessions, allowing it to pick up where it left off, execute complex multi-step workflows, and continuously improve task performance over time. This makes the agent a long-term collaborator. The Skills architecture is a modular plugin system connecting the AI to over 100 applications and services. This universal adapter turns a general-purpose language model into a specialized expert for tools like Notion, GitHub, Slack, Linear, and Calendar. OpenClaw is an AI that does things. It moves past suggestions and provides actions. This capability transforms language models into autonomous digital workers that can navigate the full complexity of your digital environment. Chapter 2. The Uncomfortable Truth, Security Nightmares. OpenClaw's power also makes it dangerous. Giving an AI agent broad access to your digital life creates a threat surface that most organizations and users are unprepared to defend. The default security posture is built on an optimistic model, assuming users will vet skills and monitor behavior. However, this assumption is rarely met, leading to a reality gap in skill vetting, permission configuration, and agent monitoring. This creates the attack surface problem. Connecting OpenClaw to multiple sensitive systems creates a single point of access. Every API token granted is a potential vulnerability, exposing email, file systems, API keys, and code repositories in a single breach. A real-world incident involved a malicious Twitter-enhanced skill. Over 800 users installed it, allowing it to silently exfiltrate authentication tokens and message history. Key takeaways include no automated detection, trust through popularity, and silent exfiltration of data. CVE 202625253, rated CVSS 8.8, allowed one-click remote code execution. A single crafted URL allowed token exfiltration and full system access, compromising digital identities and all connected services. The problem lies in the architecture, not just a bug. Safety mechanisms, like the sandbox, can be disabled programmatically via API calls. Permissive defaults and a lack of privilege separation contribute to the architectural weaknesses. Internet scans reveal thousands of exposed instances with no authentication. Default installations prioritize rapid demos over secure deployment. This includes zero authentication required out of the box and over 800 malicious installs of the, quote, Twitter-enhanced skill. Every connection is a potential breach. Every token granted is a door left ajar. OpenClaw's power and its peril are inseparable. Understanding this is the first step toward responsible deployment of autonomous AI agents. Chapter 3 covers the AI-specific risks. Beyond traditional vulnerabilities, OpenClaw introduces new risks unique to agentic AI systems. These emerge from how AI agents fundamentally reason, combine information, and make decisions. Ambiguous intent interpretation is a risk because natural language is inherently ambiguous. An innocent query can trigger the AI to expose highly sensitive data. For example, asking to see the, quote, security configuration might surface API keys and credentials, which was not the user's intent. Cross-source data combination is subtle and dangerous. The AI can combine information from disparate, non-problematic sources, inadvertently exposing proprietary data. Sources like GitHub PRs, Notion docs, and Linear tickets, when combined, create a comprehensive picture of sensitive IP. Conversation history retention poses a long-tail risk. OpenClaw's persistent memory, while celebrated, means chat logs may contain sensitive data indefinitely. This includes credentials, business logic, and personal information, all searchable and accessible to anyone with system access. Autonomous access decisions are perhaps the most profound risk. Agents can make consequential decisions without direct human oversight. This can lead to unintended actions, irreversible operations like deleting files, malicious exploitation at machine speed, and cascading failures in workflows. A lack of transparency creates an accountability gap. Organizations deploying OpenClaw lack critical security documentation like SOC 2 certifications and independent audits. Without this foundation, informed risk decisions cannot be made, leaving organizations operating blind. The data leakage landscape shows that every connection point is a potential leak, and every query is a potential synthesis of sensitive information. Security must be treated as a first-class design requirement, not an afterthought, to manage this vast attack surface. Chapter 4 discusses the future impact of OpenClaw, transforming industries. Despite current risks, Agentic AI will fundamentally reshape industries. The question is whether organizations will be ready for this economic transformation. In healthcare, Agentic AI offers huge opportunities to reduce administrative burden. However, HIPAA-compliant deployment requires a rebuilt security envelope, strict isolation of protected health information, and clear tiered privileges. For business operations, Agentic AI promises automation at scale, handling large swaths of digital work. This includes always-on operations, automated negotiation, and seamless workflow automation, offering staggering ROI potential. In software development, OpenClaw is a force multiplier. It automates code review, debugging, CI/CD pipelines, and responds to production incidents autonomously. Engineers are already seeing this in real-world scenarios, where the AI handles the full incident response lifecycle. For personal productivity, OpenClaw is the true digital assistant. It manages complex modern life, assisting with travel booking, personal coding, email management, and financial tracking according to defined preferences. The promise of Agentic AI is not just efficiency, but the liberation of human attention. When mundane tasks are handled autonomously, people can focus entirely on what only humans can do: create, connect, and decide. Chapter 5 covers use cases, bringing OpenClaw to life. Abstract capabilities solve real problems across specialized enterprise workflows and everyday personal productivity, showcasing the potential of autonomous AI. Use case 1 involves prior authorization in healthcare. An OpenClaw agent can autonomously gather patient data, verify payer policies, and submit authorization requests, dramatically reducing administrative time and freeing up clinicians. Use case 2 is automated customer support triage. An OpenClaw agent monitors incoming tickets, categorizes them by urgency and topic, retrieves documentation, and drafts initial responses. This greatly reduces first response times and allows human agents to focus on complex, high-value issues. Use case 3 is code deployment and monitoring. An OpenClaw agent configured for CI/CD pipeline management acts at machine speed to monitor, diagnose, and remediate production incidents, maintaining a full audit trail with minimal human intervention. Use case 4 is personalized financial management. The AI financial partner monitors spending, identifies savings, flags transactions, and suggests investment strategies. This capability requires robust authentication and explicit consent flows for every financial action. Use case 5 is research and information synthesis. An OpenClaw agent can scour academic databases, news archives, and patent filings, synthesizing findings into structured reports with citations in a fraction of the time traditionally required. OpenClaw is one platform with infinite applications. Its agentic architecture is flexible enough to serve any workflow, from hospital corridors to enterprise pipelines, wherever intelligence meets action. Chapter 6: The Path Forward, Building Trust and Security. The adoption of Agentic AI is inevitable. The critical challenge is ensuring they are adopted responsibly, requiring a fundamental change in how security and trust are designed. Securing OpenClaw requires rebuilding the security envelope from the ground up. Key pillars include robust authentication with short-lived credentials, strict vetting for all skills, and a tiered privilege model with clear permission separation. Trust is earned through verifiable transparency. This requires comprehensive security documentation, independent compliance certifications, immutable agent audit trails, and regular third-party penetration testing. User education and best practices are vital. Users must understand the risks of granting an agent access and must be equipped with knowledge on skill review, the principle of least privilege, and regular access reviews. The future is autonomous, but it must be secure. OpenClaw is a historic leap in AI capability, but realizing its full promise requires an industry-wide commitment to security-first design, radical transparency, and responsible deployment practices.